Okay, so the last section in our chapters is graphing inverse functions. And you guys saw inverse come up a couple ways. For you, since we do this so quickly, what was the inverse of 3, 2? 2, 3, no. 2 done, checked out. Good, 2, 3. Remember we just switched the spot of x and y. Now, if you guys had the inverse of an equation, one person, do you know the first step? One person, ask, go ahead.
Is it x equals 2y?
Perfect. Yep, you got it. Again, now after you guys switch the spot of x and y, we just solve for y. So we're going to minus 3. So we have x minus 3 equals 2y. Divide by 2. Yep. So that was it. Answer. Good. So you guys have seen inverse come up with ordered pairs. When we had an equation or symmetrical functions. Today what we're going to do is just graph the inverse trig function. So you guys saw the inverse trig function with the word arc, or where you had that little -1. Those were both ways that you represented inverse. Now, they look a little funky on your calculator. If you guys have just the sine, right? Just the sine curve, like the one in red here. Okay. Whenever we were looking at the inverse of a function, it was a reflection over this line y equals x. And the line y equals x, is always a diagonal, right, through the first and third quadrants. This is always the line y equals x. So if we were going to do a reflection around this line, what should be produced is the inverse function. So we kind of went around this line. I took all my little points and reflected them around them. What we end up getting is a nice little curvy sine line, okay, but it looks like this. Okay. Just like the sine line, on the x-axis, this one kind of goes over the y-axis. All right, so it's the same kind of shape. We're basically switching the spot of the ordered pairs. Okay, so let's just practice some graphing, and I want to make sure that you guys kind of understand what's going on in your calculators. Okay. So with regular sine, right, with a regular sine curve, where do we start? 0, good. So if we went to 0, what's our amplitude here? 1. So it was 0, halfway through is 0, and ends at 0, but it only goes up to 1 and down to -1 between. That would be like one full sine curve that you guys would graph. In the other direction, kind of the same deal. Okay? It's 0 halfway through and at the end, and it has to go to 1 and -1. So we get a nice little sine curve. I feel like you guys are very good at graphing sine curves, not only recognizing them. Okay. So when we do the inverse of sine curve, all that's going to happen is we're basically doing the same exact thing, but it's going to go on the y-axis. Now, one thing that you guys want to, easy way to tell which is which, sine, you knew started at 0, right? It had the point 0, 0 in it. So, using the idea that we could flip our ordered pairs, what does arc sine have to hit too? 0, 0, right? Because we just flipped the spot of x and y. Let's graph this in the calculator so we can really make sure we understand what way at least the shape should be going. So what do we do? So we're going to go to y equals. Right? Make sure we are in radian mode because we're graphing. And we need to go to second sine. Right? That's how we get the inverse or the arc. Put your little x in. Okay. Right, and then we're going to graph. Right, this is right if you guys got something that looks like this. Make sure if you need to do Zoom 7, Zoom Trig will get you those the bigger like you might have to in yours. Yeah, okay. Just anybody who's borrowing one that's from Wisconsin, I gotta think big about that. Okay. Does everybody have this up? Alright. Well, on our picture, it was supposed to look like this thing in blue. Right? We can tell a part of it kind of looks like that. If we look at our calculators, all right, we know we have a 0 here, and it looks like it's going this way first and then this way. Yeah, exactly. It just goes through the other axis. Now, when we look at this part, all we had on our calculator was something that looked like this. Right? Well, what Andrew said was, when you have this flip, the sine curve, I didn't do it all together. Sometimes I can group it. Sorry, I was going to try to make this whole red thing go. Let's do this part. Sorry, I thought it would be better if I flipped it, but let's look back. That looks stupid to do. Didn't go what I was planning on. Sorry. Okay. Is this part okay with where I got that from? If you look at your calculator?
Yeah.
Okay, it looks just like that. Now, the reason why your calculator should have had something that looks like this. Isn't that what the sine curve would be if you just kept going with it? Nice wavy.
Yeah.
Right. Anybody have any idea why it doesn't show you that? No? This is kind of tricky. Yeah, Kate? Yes! Holy cow! Good job! Very nice. Is this a function? No. Your calculator, this is not a function. Not a function. So what your calculator does was it stops it while it's a function. So what it does is it stops it here and here before the graph can turn back around. Because otherwise, if you tried to do the vertical line test with everything, would it pass?
No.
No. So if we take those out and we take these out, now it passed the vertical line test? Yep. So it will only graph things that are functions. That's why your calculator can't graph a complete circle, because a circle is not a function. Yeah, it can't graph things that are not functions. So what it does, it just cuts it. So if you guys did like arc sine, you know, I hope that we can, you know, decide that, yeah, it's a sine curve, it would really just follow this kind of good pattern, but if your calculator won't show you that. The big thing is that this one's going to hit at 0, 0. Now the next one, if you guys were going to do a cosine curve, cosine, if you guys were going to start a regular cosine graph, right, it started at whatever the amplitude is, so this would be like 1, okay, it went negative 1 halfway through, and ended at 1. So it had that nice little like horseshoe shape, should make it a little bit. Right. There we go, so something like that. All right, now when we are dealing with arc cosine, if this is going to be the 0, 1, what should you guys have over here? 1, 0, good. So what's going to happen now, when we look at the arc cosine, it should kind of be in this part, like at a 1, 0. So let's graph this, arc cosine. So we're going to do y equals second cosine. Is everybody able to get their graphs up? Just checking. All right, so this one looks very similar, right? But does this one go through 0, 0? No, but the arc sine does. So if you guys kept this one going, it would look something like that. And right, it's not a function, so again, that's why your calculator cuts it at those two spots. So, put a little picture here. Looks something like this. And you guys don't have to be exact. What they're going to give you, and I did it for your homework, is like reasons questions. Just like yesterday, how your homework was, how you just match up the picture to the correct answer there in multiple choice. That's what you guys will see with the graph parts of these. Now, if they're going to be really, really mean, okay, once in a while these kind of crazy ones show up, where they're going to give you guys wording about like the domain and the range of these. Okay, and you really want to use a calculator. So take a look at this first question. Oh, either one's are correct. So sometimes it's multiple choice, sometimes they make it like big, or sometimes they just give you a little snapshot. So it just depends what they ask you. You won't physically have to graph it. It'll be a matchup question like Carly said yesterday. So this is, I think, a very difficult question to understand. They're saying, in which interval of cos x is the inverse a function? Right. Well, what is the inverse of cosine?
1 over cosine.
So that's going to be the reciprocal. Good, nice, Haley. Cos negative 1, right? Or arc cos. That's going to be what the inverse is. So they're saying, where is the inverse going to be a function? Well, the easiest way to kind of tell about something being a function is where it can exist. So if we
Number 1.
Oh, okay, so keep it right here. All right. So we took our arc cosine, which we have in here, and I graphed it. All right. How can we get all the ordered pairs? The second table. And this is a little kind of weird. Okay. Here. See where you guys have all these errors? Can it exist there? No. No. Okay. So let's kind of figure out where it's going to actually work. All right. So when we look at our little okay, good. So let's look. We have between which part? 1 and -1. And when you're looking at, is the inverse also a function? Do we have between 1 and -1?
Mm-hmm. No, but no.
Well, yeah, you have x's, and let's look at this one part too. Okay. What is 3.1416? Anybody know? Pi. Good. Right. This is what pi is, right? This will come up. If you guys are in radian form right now, they're not going to give you like pi over 2 or just pi. They're going to give you things in decimals and have you like see what they would be. You all know 3.14 is pi, right?
Can't you just look at the picture and see that it's not all the way to the...
I guess you can. I mean, and then this is just 0, right? Okay, so when you guys are looking at this, it's a little weird, right? You want to look and see where does it exist. It does not exist in this part. It doesn't exist in this part. Use this for help. So this is 0, and you said that was like pi. So when we go to our answer, which one's 0 to pi? 3. They're very. I've only seen like 3 of these ever come up on like 10 exams, and they're just very odd because when you guys are looking at something being a function, usually the x doesn't repeat, right? So it's hard to look at the picture to figure out where the x is repeating and where it's not repeating. So when you're looking at your calculator, pay attention to where you're getting the errors and look at these numbers instead, right? Very like odd stuff, but once in a while you might get one of those. That'd be the hardest thing they ask you. Let's look at this one. Which statement regarding an inverse function is true? And so here we're dealing with sine and arc cosine, right? Both of them. So since we have arc cosine up, can we look at that one first? All right, thanks, Karen. Okay, so let's look at this one. So they're saying the domain is between -infinity and +infinity. That means that this would work at every x value. It's -infinity, +infinity, it never fails. Does this one give you a value at every x?
No.
No, right? You get errors in some places. This can't work. Right, so we can't use, we can't use that one. Right. Now this one says the range is 0 to pi. Is range the x or the y? The y. Okay, so here's your...
True.
You think this one's true for you?
Maybe. Which one are we on for?
Yeah.
Yeah, that's true.
Okay, yeah, this one looks pretty good. 0 to pi, right, in the y coordinate. So, all right, I'm going to hold off because I want to make sure that this is definitely going to be it. I'll put a star. That one looks pretty good.
That's what we just did.
I know, it is. So this is kind of like the same type of question that's come up twice. Let's try the signs and make sure, see what's up with those. So if I put in y equals arc sine, let's graph this thing. And we'll pull up the table, second graph. Okay, let's see what happens with this one. Okay, so we get errors again. Now, I don't know what this is, right, as a decimal. Maybe you do. I don't know off the top of my head. So we might have to figure it out. It's not as easy as just the pi. Oh, how did you guys know that?
It just makes more sense.
It makes more sense?
Yeah.
Okay, well, let's see. If we weren't sure, right, we know that that 3.14 was the pi. So let's see if I did, let's see if I tried pi over 2. Oh, that's the same number, right, that we had before?
Mm-hmm.
Okay, so, all right, that's looking good. So now at least we know. This would be like negative pi over 2 then, and this would be like your positive pi over 2.
Yeah.
Okay. All right. Okay, so the domain is 0 to 2 pi. Let's check this thing out. All right. So the domain, does it work from 0 to 2 pi? If this is only pi over 2, this is like 0 to 90. Will it work down here?
No.
No, you're going to get those errors, so that's not going to happen. All right, I'll cancel this one then. The range is -1 to +1. Let's check that out. -1 to +1. What do you guys think about that? No, I mean, it's got more than that. It goes to -1.57 or +1.57. Or they could have done from negative pi over 2 to positive pi over 2. It doesn't just go to -1 to +1, so it can't be that one either. So it has to be choice 4. But you need a calculator to do this stuff. This is not things you guys are going to want to do like in your head or like pencil paper style. Okay? This is like the easiest way to do it. And those honestly would be, I think, like the hardest type of questions you guys get on your Regents exam. But using a calculator is
Like
very
the
helpful.
hardest ever.
I think that's like a multiple choice, probably. Let's just do a quick little tan, arctan. Okay. So when we did tangent, we did this one yesterday, tan x. When we graph this thing. We talked about yesterday, what were these lines called? Asymptotes. Good job. Okay, so we got some asymptotes going on with the tangent. We want to just do a quick little sketch. It doesn't have to be great for right now. Okay, so we have stuff that looks like this. Oops, that one's not a good one. This one go up? Close. All right. You guys aren't going to have this kind of good graph. Now, arctan, let's see what happens here. Y equals second tan. Isn't this kind of weird? How are you guys doing back there? Graphing? Andrew, graphing? Yeah. Great. Okay. So, good. All right. So here's your arctan. Now, if you guys graph the inverse of tangent, wouldn't you expect to see, more of those lines?
They want to be able to see that.
You can't go to the line.
Good, yeah, because it's not a function, so it can't do this. It's only going to show you just the one, all right? So really what's going on is all those lines, but our calculator's not going to do it because it's not a function. All right, so arctan looks like this. What do you think's going on this side of each of them? Well, if you had this and you did like kind of keep graphing it out, when we were looking at tan this way, you had asymptotes going up and down. What do you think is going to go the other way? Yeah, good. Horizontal asymptotes will go this way. Okay. So they're still going to be broken up with things. Everything's just kind of switched. So here's a tricky multiple choice question as well. All right, so they say tan x is defined in such a way that f to the -1 is a function. What can be the domain of f of x? All right, so what this is saying is a little tricky with this. See how f of x equals tan x? Okay, so f to the -1 is really, who can tell me what is f to the -1 going to be? The inverse. All right, so tan -1. All right, that's what they're looking at. That this is a function. What can the domain be of f of x? All right, so let's figure out some stuff here. This is a lot of very odd wording in here. So let's graph. We have our tan x. Right?
It's like the hardest thing to see.
Yeah, something like this I think would be the hardest one. And this would be one, guys. You know what? If there were 60 of you taking this test, maybe 10 of you might get it. So if this is like confusing to you, I would not stress about it.
There's no error.
Okay. Yeah, this is a little weird. So here's your arctan, right? We move it up or down. Do you have any errors going on? No. All right. So let's see what else maybe we could do. When they ask you guys about f of x, what can be the domain of f of x? What is f of x? Is that the inverse or the original?
The original.
The original. Okay. So let's see what we know about f of x, or just tan x. They like to put this crazy wording in here to try to trick you guys. Very, very tough. Tan x. Let's see what we know about this thing. Second graph. Okay. All right.
There's no name.
There's no errors in this one too. Okay, so we're really gonna have to be careful with this, right? When you guys were looking at your, oh, you know why? Right? Think about it this way. When you're looking at the domain here, right? That's where it can exist. Okay. So if you looked at this, would this be a function?
Yeah.
Yeah, right. Technically, you don't really have things that aren't functions here. So when we looked at our domain, this might help you guys too, looking at it as a picture here. Here's your pi over 2, pi, 3 pi over 2, 2 pi. Let me start all this out. Here. 3 pi over 2, then 2 pi, then it's a 0. Okay. So when we go through our options, let's see what happens with 0 to pi. Okay, looking at a picture. So if we look from 0 to pi, do we have a tangent at every single point between this?
No.
No, where can we not have one?
Pi over 2.
Yeah, the pi over 2. So it's not going to work in here because that pi over 2 is not working right at that spot. Okay, let's try. We can't do choice 1. Right? This one's not going to work. So let's do 0 to 2 pi. And notice, does this mean it includes or does not include? The lines underneath. It includes. Okay, so let's try 0 to 2 pi. So if we include it here, all the way in here, is it going to work at every single spot between?
No.
No, again, it's not going to work at these lines because of those asymptotes. So it can't work here. All right, this one's saying it does not include, right? Let's see, negative pi over 2 to positive pi over 2. Let's just see those. So it's saying from negative pi over 2 to positive pi over 2, but not including those exact lines. So everything's right between. Would that one work?
Yeah.
Yeah, that one looks like it should be good. Okay, so I'm going to circle that. Let's see just quick about the other one. So negative pi over 2 to negative 3 pi over 2. So here's negative pi over 2, negative 3 pi over 2.
3 pi.
It's just 3 pi over 2. It's not
Oh, it's just, oh, it's not negative. Good. Yeah, I would have got that wrong. We're reading too fast. Okay, let's see, negative pi over 2 is all the way over here. Is that one going to work? No. Okay. Those would be, guys, the hardest type of questions you would get on this. What I gave you for your homework is what the matching of the graphs would be. I just wanted to make sure we went over the hard stuff in case you guys think that kind of a lot of detail. You only have 3 questions. We're not going to do the fourth one. All right, you don't have to do the graph. You want to do it? You can probably cover it now, actually. Really quick.
Mrs. Mason?
Yeah.
Did we already take the quiz?
Yeah. Andrew?
He's looking back at me. No, I looked at this twice. Because you might as well.
So there's no number 4.
Nope, no number 4. Right.
Oh, maybe.
Oh, gosh.
No 4?
No number 4, guys. Oh, also, can we listen up please 1 second? Can you guys look real quick at some of the numbers, right? Make sure they go up, right? When you're doing your multiple choice,
Yeah.
they're kind of oddly proportioned on this.